Greetings everyone! Dear MIL 2021 conference participants, I'm Nenad Petrovic, a teaching assistant at the Faculty of Electronic Engineering, University of Niš in Serbia, from the Department of Computer Science. In what follows, I'll present you the paper that we wrote together with my colleague Đorđe Kocić from the Department of Power Engineering, from the same faculty. The topic is IoT for COVID-19 in the SPAD prevention, cough detection, air quality control, and contact tracing. We're all witnessing that since the beginning of 2020, COVID-19 pandemic has influenced almost any aspect of our everyday lives, from entertainment and education to healthcare and transportation. Most of the existing processes and daily routines have been actually reshaped in order to comply with safety guidelines that COVID-19 pandemic has brought to us, either indoors or outdoors. In this paper, the main topic is to explore how cost-effective IoT-based solutions in synergy with state-of-the-art technologies such as embedded machine learning and blockchain, together with mobile applications, can be adopted to reduce the spread of coronavirus, especially indoors. As the outcome of this research, 3 case studies are presented. The first one is actually deep learning-based cough detection and classification, which is executed on Raspberry Pi. The second one is actually how RFID, together with blockchain technology and smart contracts, can be used for contact tracing. And final case study is air quality control based on affordable Arduino Uno device. Now, let's see some basics about COVID-19 protection and spread reduction. Tracing the interactions of infected persons with other persons, especially indoors, is one of most effective preventive measures when it comes to reduction actually of this infectious disease. There is high risk of COVID-19 infection spread indoors on the other side, and it comes from airborne-based transmission. There are many research results that indicate that for certain values of air quality parameters like temperature and humidity or CO2 presence can actually lead to greater spread of COVID-19, like temperature between 26 and 27 degrees is quite, convenient for COVID-19 to spread, and humidity which is less than 40%. So in general, dry environment is, beneficial for COVID-19. In order to actually tackle the spread of COVID-19, we want to regulate these parameters and keep them outside of the boundaries that are good for spread, and this way reduce the number of people infected indoors. Finally, many research also indicate that distinctive cough is actually specific for infected person when it comes to COVID-19 disease, and can be leveraged as preliminary diagnosis method together with contact tracing and air quality control systems. Let's see the first case study. It's deep learning based cough detection based on Raspberry Pi. So deep learning is actually an approach in artificial intelligence that is actually aiming to enable the machines to actually learn some patterns and extract some knowledge from huge amounts of data using artificial neural networks, which have many hidden layers. The implementation here is based actually on a variant of deep neural network that is actually a convolutional neural network. And when it comes to hardware, we have Raspberry Pi 3 device equipped with microphone, USB condenser microphone, and TensorFlow Lite framework for Python, where this convolutional neural network is actually implemented. When it comes to the data set, a publicly available cough data set with both examples for infected and non-infected persons from GitHub was used for this research. So in the first step, we have microphone recording environmental sounds on Raspberry Pi Live. We have feature extraction using MFCC, and actually when we have a reduced number of features, it can be fed into neural network for classification, detecting whether the cough contains actually COVID-19 elements or not. When it comes to the actual implementation of convolutional neural network in this research, we used Adam Optimizer learning rate value 0.005 and beta 1 and beta 2 parameters with given values. We had like two convolutional layers with pooling layers between in order to further reduce the number of number of features. Average pooling method was used. The kernel size was 5 times 5. We had like 10 features in the first layer and 5 feature maps of dimensions 5 times 5 in the second convolutional layer, while for output layer we have a sigmoid function for classification. When it comes to accuracy, it was around 95% for cough detection to distinguish whether there is a cough or not in the present sounds at all. But on the other side, we have also the third class, which is a COVID-19 presence in cough, and it was around 72% when it comes to distinction between normal cough and COVID-19 cough. And the third class is no cough at all. The second case study is contact tracing based on RFID-equipped Arduino Uno and blockchain technology. For identification of persons, they use RFID tags like cards or NFC-equipped mobile devices that actually pass near RS522 affordable RFID reader, which is connected to Arduino Uno. This device is used in order to identify persons who arrive within a building or entrance of faculty hall, or for example classroom or library or any other indoor office. On the other side, it's also stored within event log, like on the blockchain using Ethereum technology, and execution of Solidity smart contract in the background is ensuring that the correct record is stored when each person arrives. And it is used as an permanent, immutable, irreversible event log. But on the other side, we have mobile application where persons who arrived and visited the building can actually use to notify the others that they were infected with COVID-19. So institution has both IDs of the persons and access to the correct blockchain records. So if one of the persons within the office or some classroom was infected, then a notification will be generated and sent to all the persons who were in this room within the given time range. So here on this slide you can see an extract from Arduino Uno code, which is actually used to identify persons for a given room, and everything is stored first into local event log using MQTT protocol is sent to a server, which later actually stores the information on blockchain. MQTT protocol is a lightweight protocol for communication between machines, actually here in this case between Arduino Uno and server. And on the right hand side you can see the excerpt from Solidity smart contract responsible for storing and retrieving the important data about the persons, rooms, and the time frame when they arrive. And the final case study in this paper is air quality control based on the Arduino Uno device and DHT 2020 temperature and humidity sensor. Here also we make use of MQTT protocol for communication between devices. So the system generally measures both temperature and humidity and checks whether it is between 26 and 27 Celsius degrees, or humidity is lower or equal than 40%. In that case, we'll send using Arduino Uno activation signal and MQTT command, which actually controls the air quality regulation system involving like air conditioner devices, some filters that actually can contribute to the change and adaptation of air quality in this case. On left hand side you can see the block diagram from Proteus, which illustrates how this system was prototyped, and in case that the condition that is we have air that is suitable for COVID-19 spread, we have the red LED turned on, otherwise it would be green. So, to sum up, according to the Schindler results, we can conclude that cost-effective IoT-based solutions which aim COVID-19 in their spread reduction show satisfiable performance on one side and have strong potential on the other side for novel use cases, as they are quite capable nowadays and can actually be integrated with state-of-the-art technologies such as embedded deep learning in our case and blockchain, but not directly for blockchain. The strong potential of these use cases is especially seen in adoption within institutions like faculties, libraries, and student restaurants in developing countries where the situation regarding coronavirus on one side is critical, but on the other side, the cost effectiveness and affordability of these small size and low power consumption devices is something that is highly beneficial and could actually contribute to overall COVID-19 protection increase in many places. Thank you for your attention. This work has been supported by the Ministry of Education, Science and Technological Development of the Republic of Serbia.